Okay, today's lesson is 0.2a, operations with complex numbers, and we're going to concentrate on performing operations with pure imaginary numbers and complex numbers. Okay, so remember from Algebra 2, you learned that the square root of -1 was equal to I. So we're going to see what kind of pattern develops when we raise I to different powers. So I to the first is I. And I squared, well, what do you get if you square this number? You square I, you get I squared. Square the square root of -1, and you get -1. So I cubed is going to be I squared times I. So if I multiplied these two together, I'm going to get -I. And then if I multiply I squared times I squared, well, that's -1 times -1, so that's +1. Then if I go to I to the 5th, well, I'm going to use I to the 4th because I to the 4th is 1. So I to the 5th is I to the 4th times I. And I to the 4th is 1. 1 times I is I. I to the 6th is I to the 4th times I squared. Okay, every time we see I to the 4th, you think 1. So all I have to worry about is I squared. And I squared is -1. And then I to the 7th is going to be I to the 4th times I to the 3rd. I to the 3rd we can see is -I. And I to the 8th is I to the 4th squared. And 1 squared is 1. So if you were to keep going, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, your answers are always going to be one of these four. So whenever you see an I problem, okay, and you have to just simplify I with an exponent, it's basically multiple choice. The odd powers are I and -I. The even powers are -1 or 1. Okay, so most importantly, you need to remember that you should never ever leave an exponent on I. Okay, so, and the really key is the fact that we always, we're going to use I to the 4th a lot to simplify that. So you're going to see how that works. So first of all, I squared plus I to the 8th. Please don't put I to the 10th. You'll make your life harder because it's not I to the 10th. We don't get to add those exponents. You only add them when you're multiplying. These are examples of multiplying, so I added the exponents. So down here, I squared, we can see up top there is -1. And I to the 8th, we can see up top there is 1. So -1 plus 1 is 0. Okay? Now, just like I to the 8th, I to the 100th, 4 goes into 100 25 times. So I to the 4th to the 25th is I to the 100, and I to the 4th is 1, and 1 to the 25th is 1. So that simplifies to 1. Again, I to the 4th is 1. Now the difference here is I have a negative exponent. So that negative exponent, remember, means that I'm going to put it on the bottom to make it positive. So I'm thinking of 1 over I to the 12th. And so I to the 12th is I to the 4th to the 3rd because 4 goes into 12 3 times. Okay, so that gives me with 1. I to the 4th is 1, and 1 over 1 is 1. So I'm left with 2. Okay, so here come the more challenging problems, and that is if 4 doesn't go into this number evenly. Okay, so what you can think of is you want to know how many times 4 goes into 18. And why you're always going to use 4. Why am I always going to use 4? Because it's I to the 4th, like we just talked about, is 1. And so that kind of gets rid of all the extras that we have. So how many times does 4 go into 18? And 4 goes into 18 4 times with a remainder of 2. So how many times it goes in is basically the exponent that I have on there, and I don't need to worry about it because that part of it is 1. But the 2 is going to be the exponent of what we have left over. So it's I to the 4th raised to the 4th times I squared. And I squared is -1. So that's where that 2 is coming in. And 1 times -1 is -1. So that's how what you want to remember when you are simplifying complex numbers. Imaginary, the letter I, the number I. Okay. Remember, a complex number in standard form the standard form of a plus bi has two parts. It has an imaginary part, bi, and a real part, which is a. Okay. So Therefore, the set of real numbers is a subset of the set of complex numbers. So here are our complex numbers. One part is real, one part is imaginary. If there is no real part at all, we call it a pure imaginary number. Okay, just so you don't get confused if you hear that in the future. All right, what do you have to know how to do with these? To add and subtract them, you're going to combine like terms. Okay, just like you've always learned in algebra. So my like terms here are the real parts, and the real parts, 7 and 2. And when you add those together, you get 9. Okay, the imaginary parts, negative 4i, negative 3i, give me negative 7i. And that's all you got. Okay, over here, negative 3 minus I minus parentheses 4 minus negative I. Okay, these are my real parts, negative 3 and positive 4. But you got to remember that you're subtracting. So you got to distribute that. So negative 3 minus negative 4 is negative 7. Okay, and then my imaginary parts, negative I, negative 5i, but I have to distribute that, y'all. So that's negative I minus negative 5, which is basically negative I plus 5, and that's going to give me plus 4i. And that is what we got. All right, one more example. So adding and subtracting, and then we're going to talk about multiplying. So to multiply, you're going to use the distributive property, probably not what you're thinking about, but that is what we do when we multiply. Okay, now look at 18. We have negative 2 minus I quantity squared. Okay, squaring things, y'all. It is a special case. And if you can remember correctly, when you multiply out, okay, you can FOIL it if you want, okay, because that's the other method that we have of multiplying and using the distributive property, but you can only use that with two binomials. But back to A minus B quantity squared, you square the first one, you keep this sign the same. So if that's minus, this is going to be minus. Then it's 2 times the product of the two things inside. You ignore the signs, y'all. We already took care of the sign with the minus. And then you square the last term. And since you square it, it's always positive. So that's what you get. So watch, when I put this together, I'm going to have, first off, negative 2 squared. I keep the sign the same. And so when I keep the sign the same, I have a minus. And then I have 2 times A, which is negative 2, and B, which is I. So don't put another negative I in because I already took care of it at the beginning when I put this negative sign right here, because I put this is always the same. So that means my A is negative 2 and my B is just I. All right, and you're going to square the last one so it's always positive, which is why I ask people to not put a negative in there, because if they don't put the negative and they don't put the parentheses and they forget that it's always positive. So that's what we have. To simplify, negative 2 quantity squared is positive 4. 2 negatives makes this plus 4i, and plus I squared is what you get. And I squared is equal to negative 1. So when I simplify, my real parts are going to be 4 and negative 1, which together give me 3. And then I have plus 4i. So that's how that simplifies. All right, last example. I have FOIL. I'm going to use FOIL, okay? The FOIL acronym stands for the first term. So that's 2 times 4, which gives me 8. O stands for outside. 2 times 3i gives me plus 3i. I stands for inside. So I times 4 is 4i. Again, both positive. And L stands for the last terms. And I times 3i is 3i squared. Sorry. Just one second, almost done. At 3i squared plus 3i squared, the I squared changes your plus to a negative. 8 minus 3 is 5, and 10, Pooh Bear, got the wrong one, 5, and 6i plus 4i is 10i. And that is all there is to this lesson. Hope you all enjoyed it. If you have any questions, please don't hesitate to email us or contact us in some way. Thank you so much, and y'all have a great day. No! Next time you could just kind of like keep walking.
I'm sorry.
I just wonder how many of them are going to be scared.